Hello students, and welcome back to Chemistry A. I'm Ms. Slate, and today we're going to be talking about ionic compounds and how to write their names and formulas. So first off, why is it that sodium and chlorine will come together to form the compound sodium chloride? To figure this out, we need to look at how the electrons are arranged in both of these elements. So if we look at the electron configuration of sodium, we can see that it has 11 total electrons and 1 valence electron. So its Lewis dot structure has 1 dot on it. When we look at chlorine's electron configuration, we can see that chlorine has 17 total electrons and 7 valence electrons, 2 from the 3s and 5 from the 3p. So its Lewis dot structure has 7 dots around it. Now, how atoms form bonds is governed by something called the octet rule, or the rule of 8. And it's simply the tendency of an atom to gain, lose, or share electrons to have a full valence shell. Meaning that when atoms come together to form bonds, all of the atoms want to have their outermost energy level completely filled with electrons. So if we look at sodium, it has just 1 electron in its 3s. So if we're to lose that 1 electron, its second energy level is now full. Chlorine, on the other hand, is only missing 1 electron from its 3p. If it were to gain an electron, it would now have a full third energy level. So let's kind of see how this works with the dot structures. So we've got sodium and chlorine. Sodium is an alkali metal. It has a very low ionization energy. It's very apt to lose electrons. Chlorine, on the other hand, is a halogen with a high electronegativity, which means when chlorine forms bonds, it's going to very strongly attract electrons. And that's exactly what happens. Sodium loses its 1 valence electron to chlorine, so now they both have full valence shells, and it becomes a sodium +1 ion and a chlorine -1 ion that are attracted together to form the compound. Now let's watch a short clip that shows exactly what this reaction looks like in real life.
Sodium metal is heated until it melts and just begins to burn. Then it is immersed into the yellow-green chlorine gas. The sodium begins to burn in chlorine with an intense yellow flame. It produces the white smoke of sodium chloride. We are observing the exothermic reaction of sodium metal with chlorine gas, producing the white solid sodium chloride. Afterwards, the glass spoon contains only white solid sodium chloride.
Now let's talk about some of the properties of ionic compounds. First off, in ionic compounds, the atoms exchange electrons to form a more stable, lower energy system. And when bonds form, energy is released. The structure of an ionic compound is called a crystal lattice. It's just a repeating pattern of ions. And the positive and negative ions will always arrange themselves in a repeating pattern that balances charges, meaning the final compound will always be neutral. The charges of the ions will add up to 0. And these ionic crystals have very strong, rigid structures to them. Now let's talk about some types of ions. First off, there are cations. They're typically formed by metals. And a cation is just an atom that has lost electrons and has a positive charge, like sodium. On the other hand, there are anions. Anions are ions that have gained electrons and now have a negative charge, like chlorine. Now, the way I remember the difference between these two is that I remember that cations are positive, like a kitty cat. Lastly, the chemical formula for an ionic compound is what's called an empirical formula, or a formula unit, and it represents the simplest whole number ratio of the positive to negative ions in the compound. For example, sodium chloride is a 1-to-1 ratio of sodium and chloride ions. So if we look at this picture here, we can see in the crystal lattice there is more than just two ions. There's more than just one sodium and one chlorine. All of our chlorine atoms are surrounded by and attracted to positive sodiums. All of the sodium ions are surrounded by and attracted to negative chlorides. But this would be almost impossible to represent with a formula. So that's why we always go for the lowest ratio of the ions. So the formula unit is just that simplest repeating pattern that you'll see in the crystal lattice.